I am starting the recording now. Okay. So welcome to this workshop on VMware virtualization. I welcome you all on behalf of Career Guidance Council. You might know CGC, but let me give you a bit of introduction on that. CGC is basically an NGO based in Hyderabad, and we have been, of course, working on helping the community in terms of career guidance, I think more than a decade now. Our goal is very simple. We just want all of you to learn the upcoming technologies and get a good job and earn your survival. That's the whole idea. And we are trying to help the community, that's all. So out of that, of course, I'm very thankful to the CGC for giving me this opportunity to run this workshop. And in this workshop, I'm going to build a foundation on virtualization for you guys. I'm pretty sure if you guys pay close attention to my training, you will be one of the leading virtualization experts in the market. That's for sure, right? Why? Because what I'm going to teach in this training is not something that you might always get to learn outside the market, because the market is focused more towards a set of curriculum, right? And what I've built here is something which is out of the box and something which is really required for you guys. This training will really help you to build a strong foundation in virtualization. So what I've done here is I have prepared a curriculum which is more like it starts with the foundation for someone who's very new to virtualization, who doesn't have any prior experience in terms of information technology. Even such kind of people can join this. And then I'm going to start with that basic foundation, and then going to build such a strong uh, foundation to this class is I will take you right up to the architect's level, right? So I am getting this message that some people are trying to record the session. Don't worry about it. I'm going to record it and share the recordings. So I don't want everyone to keep, start recording the session. So what I was saying was, it's going to be more like we'll start with the basic fundamentals, and when we'll try to go on to a more of an architect level. So, right, my request is we are taking a lot of pain to build this curriculum and of course teach you guys just for you, right? We want you to learn. We want you to grow in your career, right? That's the whole idea. If you guys don't pay attention to this class, and if you're just kind of logged in on your phone and just watching television and talking to someone else while the session is going on, then I would say you're wasting your time. I think it's better you exit out of the class and just concentrate on what you're doing right now. So for next 2 to 3 hours, what I want is I want you guys to pay close attention to my class, right? And if you do that, I promise that you're definitely going to get a lot of knowledge in virtualization. That's for sure, right? So let's see what I'm going to teach now. This is the agenda on the screen that you've got. So it's a 3-day class, right? It's going to be running for 2 to 3 hours, right, every day. So Monday, Tuesday, and Wednesday. What we're going to be doing is we'll start with basic fundamentals. Let's do that, right? We'll start with the need for computers, why there was a need for having a data center, why there is a centralized management system requirement, why then, what is the history of virtualization? Why did it come into existence? What I personally believe is, unless you don't know why this thing has come into existence, you would not really understand that, right? So if you know the pain point, and then you realize that, oh, to fix these kind of problems, we got this thing to the market, then is when you really understand the importance of virtualization, right? Not just virtualization, for anything in the market, right? When people had problems walking long distances, We have discovered bicycles, then we have come up with motorcycles. Then there was a more need for traveling. Then we came up with cars, buses, trains, and of course the aeroplanes, right? Because the more we face problems in terms of traveling, the enhancements we have started making in terms of traveling. Similarly, in technology also, especially maintaining data, right? We always had problems. The more problems that we had, the more enhancements were made and new things came into the market, right? And that's what is going on still. Even now, the discovery is not stopped. It's still going on. Virtualization is just the foundation. But we know we've got cloud now. We know that there Kubernetes came in, there's Dockers came into the market, and there are so many other things which are coming in, right? But if you know virtualization very well, I'm pretty sure that all the other technologies you'll be able to learn much faster because now the future is based on virtualization, right? So let's first of all get into something about understanding um, what are data centers basically and what is a centralized management system. And another important thing I would like to say is anyone who really wants to learn, right? There is always a question that comes inside his heart saying that, why should I learn this? Right? And if you get an answer to that why, I'm pretty sure you will focus more. And let me tell you why. Why should you attend this training and why should you learn virtualization? I'll tell you why. If you get a job in IT, right, you might think that, well, I would be paid as per the market requirements. I know that. But let me tell you the fact which is inside the organization. Your salary is based on the kind of criticality you're dealing with, right? For example, if you're working as a desktop engineer who's fixing a laptop or a desktop, the criticality is very low because if that laptop goes down for an employee, the impact is minimal. And imagine, similarly, there is a server which is sitting in the data center. If that goes down, all the client machines which are connected to that server will go down. The impact is going to be huge. So the higher the impact, the higher the salary paid to that employee. Now, because you will be placed in the data center, if you're a virtualization expert, obviously your salaries will be much higher than all the other people. And you know this, 70% of the cost of any organization which is set up new goes into data center, which means if I'm spending like $1 billion to set up an organization, 70% of that cost goes in only into the data center. So imagine the amount of investment a company has to do and the amount of maintenance they have to pay to maintain these data centers. And of course, people who are working in this are going to be highly paid, of course, compared to all the other jobs, right? So let's first of all understand this foundation. You might be thinking, there are so many other things in the market. Can I learn SAP HANA? Can I go and do an Hadoop? Can I do maybe CCNA or CCNP or CCIE? I'm telling you, all these are part of data centers. First thing is you need to know what is a data center. Within that, all these things fall in. Cisco falls into the data center. Microsoft falls into data center. The databases like Oracle, SQL, Postgres, right? The security concepts like IT security that you talk about, right? The storage concepts that you talk about. Everything that you might have heard about, big concepts, all those fall into the data centers. If you know these data centers, then of course you can pick and choose what else you want, whatever else you want to know, right? So let's first of all try and understand in reality, why do we need to have data centers, right? First of all, let me take an example, right? We all have ATMs, right? ATM machines. We go and withdraw the cash, right? Just imagine a situation, but if the information of a specific ATM was stored with that ATM machine itself, let's say I go to ATM center nearby my house and withdraw some cash. If that information was only stored with that ATM machine, that means if I go to an ATM center which is not at my home and again try to withdraw, there will not be any synchronization. The other ATM machine would say you have not withdrawn. It would keep allowing me to withdraw the money. That way, all the banks would have gone bankrupt till now. They all have to be centralized, so much centralized that even if I have an account in India and I come to Saudi Arabia, withdraw the cash, it should still synchronize and show that my account balance is this much. That's what it is. That is what centralized management means, right? Wherever we travel, whatever activities we do, it has to be centrally stored and managed. Not only ATM machines, anything that you manage, right? I go to a shopping mall, right? If you see hypermarkets, right, there are so many billing counters in that. You go to any billing counter, you can still do the billing and you get the bill generated, right? And that bill can be accessed from any of those billing machines. So they are all centralized. You go to any bank, you deposit the cash in one branch, and you go and check out your balance in another branch, it will show you. The ATM machines are sync. The machines which are inside the bank, the laptops and the desktop, they're all synchronized, right? And that's what centralized management is. If we don't have this, it is like we cannot survive without this. We have to have it, right? So that's what makes us now get into the reasons why we need to build data centers, right? So when I say data center, right, let me quickly take my whiteboard now, otherwise you might get bored with that. Just give me a second. I'll just launch my whiteboard. There we go. Okay. Let's take this. Let's say we have this data center, right? Let's also see that we have got some branch offices here. Let's take an example of any bank, let's say HDFC Bank, right? So let's say this is, sorry, this is my DC. So DC means data center, right? This is a branch. This is also a branch. This is a branch. All right. So what happens basically is they all would be connected through some mechanism with the networking, right? So there are some connections. These are round ones are nothing, but these are routers. Let me take this off. This, right. So let's say there are computers here. There are a few computers here, right? There are a few computers here. And here we are going to build our servers, right? Now the question is, what type of servers do you need in the data center, right? First of all, in order to maintain data, we need to have a database server, right? Now database server examples are Oracle, which are very famous in the market, right? There is MS SQL. Now we have got MySQL, right? There are many other PostgreSQL and so on, right? Now, when you go to a bank, you go and deposit some cash. Generally, they open an application, right? And in that application, they put your account number, they open those details. They they basically pull up that information. That basically comes from here because all your information is stored here. Because they all are connected, you go to any branch, they put their your account details, they actually pull up from here itself. Any entries that they make, those entries are also going to be written here, right? So this is just an example. Like this, now you would require a lot of applications to be running in your organization. For example, for a bank, they might need banking application. That's a primary requirement, but that's not enough. They might need many other applications. For example, if I'm hosting a bank, I might need a banking application. Then I would require some antivirus applications, which are going to be scanning my antivirus. I might need some security applications, which are going to secure my applications. I might need centralized account manager system because all my employees who are going to access their laptops, they will have their username and password. And they should be allowed to log in from any branch with their username and password, which means centralized user management system has to be there. For that, they will require a different type of machine. We call it as a domain controller, right? So we call it as DC as well. So domain controller is required. We call it as DC, right? And for email system, you want to have, obviously, all the bank employees would have their corporate email address, right? They will have, for example, your name at the rate hdfcbank.com. That's an official email address. That is a proof that this guy is a bank employee, right? So obviously, you need to have an Exchange server for that, right? Like that, the list goes on. For you to run the organization, you would require all these applications. Now, if your organization is too big, right, just one machine would not be enough. So just one Oracle server would not be sufficient for me. I might to have like maybe some 10 to 15 Oracle servers, 10 to 15 domain controllers, and then the antivirus servers, Exchange servers, and so on and so forth. The list goes on and on. Your data center starts becoming bigger and bigger. Now, depending on the type of application you're expert at, companies will hire you. So if you're good at databases, right, you will be managing those applications. Like if there are any problems with the databases, they are running slower, you have to take backups in case something got corrupted, you would have to restore them, right? Some entries got deleted, restore them back, and so on, right? If you're good at Microsoft server concepts, then they will hire you at managing the domain controller, that is user management system. If you're good at security concepts, they will hire you at the security. Now, security is a very vast subject. It's just not an application, but there are different levels of security. There will be securing at the application level, there is a security at the server level, there is a security at the network level, and and many other security levels, right? So these keep going on. But what we are covering now here is about just we're touching the data center. What is a data center, right? Because I'm not going to teach all these, of course. My intention is to teach you virtualization, but before that, I'm trying to explain you where does virtualization fit into this data center, right? So I am running all these applications in my data center, right? That's clear so far. I hope that is clear. Can I ask you guys to raise your hands or send me a message that it's clear so far? There are no doubts. All right, very good, very good. Fantastic, fantastic. Okay, so let's move on. Now we are clear with what is centralized management system now and what is a data center at a very basic level, right? Let's move on now. Now let's purely talk about the data center, all right? Okay, here we go. Okay, so let's build a data center, all right, of our company, right? Let us say there is a customer who came to us and we are all architects now. Let's think about architect is like, as you all guys know that I'm an architect, right? So if you're building your house, right, you go to an architect and you tell him, I want to build a house, right? And he's going to obviously draw a very good design for you that suits your requirements. And then based on that design, you're going to follow that design and then start the construction, right? Obviously, you will get those other contractors who can build your house. But the first and the foremost job is architect has to build a very good design. Now, not only that design, don't think an architect is just only going to draw some boxes and give it to you. More than that, he's also going to tell you how much raw material is required, right? He's the one who's going to tell, right, how much iron is required, right? How many bricks are required, how much of cement bags would be required for you, right? And so on. So it means all your costing is based on architect's decisions that is going to make. And he's going to make those decisions based on your requirements. For example, if I tell that I just want to build two-story building, the required iron would be lesser compared to you telling him you want a four-story building, right? He will double up the iron cost because he has to do that sizing. So if I'm building a smaller building, obviously the required iron will be lesser. The question is, how is he going to calculate that? How would he know that? Obviously, there'll be some formulas that they're going to follow. Based on that, they're going to come to a figure. Now we are going to look at that, and this is more of an architect level concept we're discussing. People say that you're talking about PhD concepts, this is architect concepts, but I'm telling you, I'm going to make it so simple for you guys, right? And definitely, if you're going to know this, I'm pretty sure when you talk these kind of things in the interview, I can challenge you that they are bound to hire you. They will hire because these kind of topics at a fresher level at least, or maybe a 5-year experience level, they would not be knowing these concepts. So we're going to talk something which is beyond 5 years experience guys, or even sometimes I've seen 10 years experience guys would not don't know these concepts. Let's talk about that. I'll try to make it as simple as possible. Right, let's have a look at it. Let us say we got a contract and we all are employees of this organization, and we got a contract, right, from some organization. Maybe we are building a shopping mall, right? Let's say we have got Lulu Mall. They have got like 100 branches across India, let's say, right? And they told us like we want to build a data center, right? We want what we want is all our shopping malls that we have, all those billing counters that they are going to run, those counters need to be centrally connected to one data center. And then all that billing information can be saved there, right? In case if customer says, I want to return this product, he can go to any Lulu Mall center, show the bill, he will put the bill number, access the details, and he can take that return. It's just going to be like that. We're just going to make it simple, straightforward for Lulu Mall, right? Now, what do I have to buy in the Lulu data center, right, if I want? So let's see. First of all, as we just talked about, we need to build few machines. Let's first of all talk about physical machines. Now, this will also tell us why there was a need to get virtualization into market. What were the problems that we were facing with the physical machines, right? So we're trying to kill two birds with one arrow here. I'm trying to explain what is a data center and also trying to tell you why there is a need for virtualization in the market, right? What gave birth to virtualization? Let's have a look at it. Let us start working together now. First of all, right, I want you guys to tell me in the chat for uh, billing information that we're going to manage centrally, what type of application should we have? Who can tell me this? I want you guys to put in the chat immediately. So billing information, it has to be saved somewhere, right? And you guys tell me what application on the data center we should have. So I'm getting a lot of replies. Very good. Some people say finance, some people say ERP, some people say cloud, some people say database, some people say Oracle, SQL. Very good. That's nice to see. All right, keep going, keep going, keep going. Some say web application, all right, some personal information. Okay, saved in database. Very good, very good. Okay, stop it now. So the right answer is you need to have a database server, all right? As I just said earlier, when you say database server, right, which means um, any database available in the market could be Oracle, SQL, MySQL, PostgreSQL, and so on, right? So here, let us say we will have a database server. But remember, to build a database server, I just cannot buy Oracle license and start installing Oracle on my machine. Let's say this is a physical machine, right? Then what do I need on this machine, right? Then I would require an operating system first, correct? Then on top of that, I would require a database, right? And there is an application server also required, right? Which is going to be a billing application, which the Lulu Mall machines would be hosting. So that machine application can go onto the billing machine itself on the Lulu Mall, right? Just like you install Swiggy app on your phone, right? That's an application which is connected to a database in the data center, right? So all Swiggy applications that you're ordering food on your from your phone, now that application is running on your phone, right? Not on the server, but that's connected to your database, right? Right. So this is a database server. We got it, right? Like this, we might need many other machines. Let's say about the user management. What type of application would you require for user management? I want you to quickly tell me on the chat. Centralized user management, right? So I'm getting answers again. Domain controllers, CRM, DC. Very good. I need a domain controller, right? Thank you, guys. Some people who are experienced might find it like we're getting too basics, but I'm telling you, we're gonna go up the ladder. We'll talk about the architect level also in some time. So because I need to make sure I keep the momentum for everyone here. So few guys are new, few are older. All right, user management, I need a domain controller, right? So for DC again, I would require operating system place, I would require Active Directory, right? Active Directory, directory services, right? So I have got the second machine. For like that, we might require many other machines, right? Antivirus, right? Security, right? Email system. Like that, I might need multiple domain controllers, might need multiple Oracle machines, right? The list goes on. Okay, at this stage, let us stop and think that we just need these these machines. We need Oracle machine, we need a DC, we need antivirus, we need security, right? We need Exchange. Let us talk about this, right? Let's say we are going to go to market now. We're going to buy this, right? There are many, right? We'll not get into all that. But the whole idea is I just want you to understand that we need some machines to be hosted on the data, on the on the data center, right? Let us say now we're all going to buy it from the market. So how would you buy it? Maybe you contact a reseller from Dell or HP, right, who are leading in the market, and we tell them, well, we're going to buy these machines. The question is, let's say as an architect, you have calculated that for an Oracle machine, um, Oracle architect will tell us, he might say like, I need, let's say 64 GB RAM, right? And maybe some 8 cores of CPU, right? For Oracle cell. Like that, all the other machines, you might say 64 GB RAM, right? Now, why 64 GB RAM? So they might say that there are like 100 billing counters, right? These are connected to cater all these 100 at the same time. You would require that much because there will be 100 connections to that. And all are writing their information simultaneously to that machine. Obviously, the resource utilization will shoot up and it may not be able to cater if you are low on the resources, right? So what we're going to do is we're going to buy it, right? Let's say we bought this hardware. Now I'm coming to the actual requirement about the data virtualization now, okay? We got this data center, right? And so you won't, so the chat is something where you can send the chat message only to the host. You can't see the chats among yourself. So it's that's how it is basically designed. The Zoom restrictions are set like that. Okay, so let us say we bought this machine. We bought this machine, physical box, 64 GB RAM, plus 8 cores of CPU, right? And we got the operating system on it, then we got Oracle running on it. Because we are assuming, let us say there are 4 connections. These 4 guys are accessing and writing their data. It might need that. Now, my question is it always going to consume 100% of the resources? The answer is no, because it would not always, all the billing counters would not be always busy at the same time. We all know this, right? Um, so let's say if the 2 machines are too busy, 2 would be idle. You might have seen many times when you go to shopping, maybe during odd times, maybe in the early morning hours or maybe during the lunch hours, you would see there is only one counter working, others are closed, because they keep it closed because they will schedule the manpower in such a way that they don't want to waste the people working during non-business hours. So they will get most of the people working even during the evening shift, because a lot of people come in the evening to do the shopping, right? So which means throughout the day, out of 24 hours, my utilization of this 64 GB RAM is not optimal at all. I am overall, and at an average, if I look out, I might be utilizing 25% of the resources. 75 would be most of the times unused. What about during the night hours? Total closed hours, maybe from morning from night 10 o'clock to morning 10 a.m., 12 hours, all the billing counters are closed. System will come down to 0% utilization, maybe just 1 or 2% utilization. Then it starts with 5%, 10% in the afternoon. In the evening hours, it might shoot up to like 70 or 80%. Then it starts dipping. That means in 24 hours, we are using this machine at optimal level is only for 2 to 3 hours. Rest all the time, it is completely unutilized, which means we purchased 64 GB of RAM for this machine, 8 cores of CPU. Let's say we invested some 1 lakh rupees for this, right? If this is just one system, it is okay. I invested 1 lakh, but out of this, 75,000 is invested out of waste because I'm not utilizing that at all. Because if you correlate this 75% with the cash, right, with the finance, it's just like 75,000 was invested uh, for nothing. Now you multiply these machines into 100. If it is a huge data center, I would have 10 Oracle servers, 10 domain controllers, 10 security machines, 10 Exchange servers, and so on. So your cost will shoot up to 1 crore, right? So out of 1 crore, right, which means now we are wasting 75 lakh rupees are wasted. You can go on multiply by with this with 1,000, that will go to 10 crores. Further 100 crores, 1,000 crores, right? Or maybe 10,000 crores. So look at companies like IBM, HP, and all Dell. These are huge companies, right? 100 machines is nothing for them, right? They would have like tons of machines across the globe, right? Their investment is like in billions and trillions. Now imagine if I'm spending like 100 crores, right? If say 75 crores are, if you get to know that you have invested 75% of your total data center investment of no use, you're not utilizing that, right? You will get the shock of your life. If you get to know that your company has invested so much, but you have not utilized it or not utilizing it. Just for the sake of 2 hours of utilization, you're just investing so much. That was the condition with the physical machines. But we had no other option. If you tell me like, okay, now I will not buy 64 GB RAM, rather I will just buy 8 GB RAM because I am not utilizing this machine at the optimal level. Let's drop it down and go and buy only 8 GB RAM. The problem we're going to face with this is during non-business hours, it's going to work fine. As soon as customers come in the evening hours, your system will hang because it will run out of resources. Now, just to manage those peak hours, right? Just for those 2 hours of or 3 hours of peak business, we will unnecessarily invest so much. The problem with physical machine is this machine, let us say there are two machines in your environment, right? Um, there are two physical machines. One machine is utilized up to 50%. Another goes up to 90%. So there is RAM available here, right? 50% free. The problem is I cannot share this RAM with this machine. It's not possible, right? You cannot share. And that means even though you have enough memory on the other systems available, your some of your systems will go so high in utilization that they will just be hanging around or just waiting to close some applications or to waiting to hang otherwise, but they cannot utilize the resources which are freely available on all the other physical machines. This is what the problem we were facing in the physical environment. Let me give you a very good example to make it more easier. Let's say we all have independent houses in our colony. These are all independent houses, and we have this water tank on each of our house, right? There's a tank. There is a right tank. Now we got this water filled in 100% on all this. Now let us say two of these houses, they have consumed all the water. The water levels have dropped. Now it's at 0%. There is no water. These two houses have very good amount of stock available, 75%, maybe 90% available. But the problem is, because there is no connectivity between these, right? Now the tank water cannot be shared across this. So even though you are all neighbors, right? You belong to same family, but you built your independent houses. Even if you want, you cannot share your resources. This is what is the problem with the physical machines. I have my physical machines. Some machines have enough resources, some machines don't. We need resources, but we cannot share those resources. That is what was the problem. And there is where the idea of virtualization came into picture. We wanted to optimally utilize our hardware resources. We did not want to waste our resources. We wanted to make sure we can share the resources whenever required. And there is where the concept of virtualization comes into picture. Now we will start talking about virtualization, right? So far, is this clear, guys? The problem that we had with virtual physical machines, that you cannot share your resources, is that clear? Can you message me on the chat or raise your hands, please? Very good. Very good. Okay. If something is not clear, feel free to message me that you did not understand this. I will be very happy to repeat that, right? Okay, that's very nice. Let us go on. Now we will talk about virtualization. Okay, right, let's go on. Okay, we just want to look at time. Okay, all right, let's move on. Now, how can a virtual machine or a virtual hypervisor, right, help us to share the resources, right? All right. Now let me explain you what is virtualization now. And if I compare physical machine and hypervisor, I think that will be a lot easier for you to understand. Physical machine, right? Let's look at the architecture of this. Physical machine is made up of what? Let us talk about the entire architecture of this. First, we'll start with the hardware, right? You have the hardware. You go and buy the hardware from the market, right? On the market, hardware, what do you get? You get a motherboard, you get the RAM, you get the CPU, you get the hard disk, and so on, right? Question is, you also need to be very clear about what this hardware basically does. Who does what? In this hardware, we have RAM, we have CPU, we have hard disk. Sorry. Right? We have NIC card, right? Network interface card. These are the primary resources that we use. We need to understand, first of all, what is the role of these things? Because without this, understanding virtualization becomes very difficult for you guys, right? Okay. The other things are there, like motherboard basically helps us to place these items, but these are the four items which are into operation always, right? These always keep working. There is also something that we do, right? After this hardware, on top of this, we install the operating system. On top of that, we install the application, right? But there is also something called kernel. What is this? Can someone tell me, guys, what is kernel? What is kernel? I want you guys to message me. Kernel. Code that talks between OS and hardware. Very good, very good. I'm getting good answers now. Interface between user and hardware. Okay. Generally has complete control. Very good, very good, very good. Very good replies I'm getting. That's nice to see. Someone says it's important part of an operating system. Someone says system libraries. Okay. I'm pretty sure you guys are not picking up the definitions and putting in there, right? I don't want definitions. I want you to really understand what it is, not just the definition, right? That's been the crux of the problems because we have mostly learned just the definitions and we just really did not understand what it is in reality, right? That's been the problem. All right, I'll tell you what is a kernel now in reality. If I'm building a house, right? What do I need to build the first thing? What is required to build a house? Can you guys tell me? What is the first thing I have to do when I'm building a hand? Building the house. Land is ready. I need to build something, right? I need to build the foundation. That's very good. Foundation, right? So I'm talking about the construction. So basement, right? The foundation. That basement has to be there. Very good, guys. Appreciate that. Basement. On this basement, right? We are going to build the house. Right. But I don't call the basement and my upper part as separate, right? This complete basement and the upper part together, we call it as a house. Correct? In the same way, any operating system that we are building, we need a foundation, right? And that foundation is nothing but is a kernel. People say that Linux is freeware, right? Linux operating system is freeware. People say this. But do you know that Linux, when you go and try to buy Linux, you still have to pay it? For example, you're buying REHL, it's not free. They will sell it, right? CentOS, they will sell it. Now, if Linux is for free of cost, why are they selling? What are they selling, right? What license is that for them, right? Now, when we say it's free, it's nothing but the Linux kernel is free, not the entire operating system. I can take the Linux kernel, I can download it, but I have to write the program, right? I need to write the code, which will give instructions to the kernel. Once I write this program to the kernel, this entire package is called as an operating system. If I just take the kernel and say it's my OS, you cannot call it as an OS. If I just take the program and say this is my OS, you cannot. Both have to be there. Just like basement and the upper part of your house make a complete house, it's just like that. The operating system has two things. One is the kernel, the other one is the operating system, the application. Now, what does this kernel basically do? So the kernel fits here, right? What does this kernel do? Let's have a look at it, okay? So we have got this physical box, okay? And here is my operating system, which I have installed, which is obviously there is a kernel as well, right? And then there is an application. Let us say I have got this notepad. I will open a notepad on my laptop. What happens when I do that? You double click and open it, right? So when you double click, what happens? Let's understand the background process here. As soon as I double click, my operate application sends instructions to my operating system saying that this is my program. The user wants to open this, right? My application, my operating system code will take that instruction and say that because my notepad is actually stored in the hard disk here. There is where you install, right? Notepad is here, right? So what happens here is, okay, guys, just wait for 2 minutes. There is Azan proclaimed here, so I have time for Isha. Just wait for 2 minutes, all right? All right. Ashhadu anna Muhammadan. Yes. Okay, so actually, I'm currently in Saudi Arabia. I just came yesterday here, so that there is a time difference. Okay, so all right, let's continue. So my notepad is in the hard disk, right? It just in the hard disk. So instructions are received by operating system. Operating system tells the kernel that this guy needs to open the notepad. All my kernel is going to do, it is going to go to the hard disk, pick this notepad, and now this kernel is going to basically give the instructions to the CPU, obviously, because kernel cannot process it, right? Kernel goes to the CPU, says that I want you to load the notepad into the RAM. So CPU is going to go to the hard disk, pick the notepad, and load it into the RAM. As soon as the RAM is loaded, the notepad is loaded in the RAM, you can see the notepad on the display. Which means there is a there is obviously a communication happening right from your application to operating system to kernel, from CPU and hard disk and your RAM, right? So there's a lot to discuss, but we'll not get into all those details for now. But understand this process. Why are we doing this? Why are we actually loading from notepad hard disk to the RAM? Why there is a need to do that? It is very simple. Hard disk comes for cheaper cost, right? Hard disk. Hard disk is more like you go down. You go to a showroom, right? You go and buy a bike, right? Let's say we all go to a showroom to buy um, Honda Activa, right? When you go to the showroom, how many Honda Activas do you see on the display? You might see five or maybe 10, depending on the size of the showroom, right? But when you go to the go down, you see like maybe hundreds of Honda Activas. Why can't they put all that 100 into the showroom? They cannot do that because showroom is costly. I pay huge rent for that, right? I cannot place all 100 Activa Hondas on my showroom. And secondly, I don't require also. Why do I need to place all 100? Just for display, right? Whatever I need, I will get it. Let's say a customer comes and says, I want to see a white color Honda Activa. If it is not on the display, I'll go to the go down, bring that one single bike, the scooter in my showroom and show it to you. And as soon as customer goes away, I will go and send it back to the go down. If I keep getting everything into my showroom, obviously I will not have any place to sit there, right? So I spend so much on my showroom. That's a display. RAM is just like that. RAM is my display. Whatever I want to use now, whatever I want to see is going to be in the RAM. Only then I can see, right? And RAM is costly, right? RAM is costly. For example, I'm buying a 4 GB RAM stick. It might cost me like 4,000 rupees. I'm just giving an example. But with that 4,000 rupees, you might get a hard disk of 500 GB. Just see the difference. Hard disk, same price, which is for 500 GB. You get 4 GB RAM. That's it. So there's a huge costing difference. That's why we put all our applications that we don't use it into our hard disk, which is like the go down. And RAM because it's lesser, right, compared to hard disk. So whatever we need now, we bring it into the RAM. But who's going to do that? All you have to do is you double click on it. Your kernel is going to process it through the CPU. CPU is going to go to the go down, get it into the showroom. As soon as you close it, it just sends it back to the hard disk, removes it from the RAM, right? This is the process basically. This is how your physical machine functions. Is this clear, guys? Raise your hands, please. Very good. Fantastic. Fantastic. It's nice. And why am I teaching all this? I'm pretty sure you might not have heard about all these concepts before, right? Because most of the times what you get to learn about the hardware is you will see what is RAM, what is CPU, and the definitions that you read is crap for me, honestly speaking. All they talk is definitions. Say CPU, central processing unit, they say RAM, random access memory. That is not going to help you to understand. I want you to understand in reality what happens, right? In reality, what these things actually do. I don't want you to just understand the definitions of it, right? So good that now you're clear with the concepts of what is hard disk, what is CPU, what RAM, what CPU basically does, what is a kernel, what is an operating system, and so on, right? Now we are going to compare this physical machine with the hypervisor, right? Now, before we get into that, let's understand one more thing. Let us say I got one physical box, right? And I want to run a Linux version of Oracle and a Windows version of SQL. I need these two applications to be installed. The requirement is I need a Linux Oracle, I need a Windows SQL. In this case, I would have to buy two physical boxes. Why? because I cannot install two operating systems on the same box. I can install if I want, one on C drive, another on D drive, but I cannot boot at both the same time, right? So when I start my machine, it'll say either you boot from Linux or you boot from Windows. So which means one machine would be dedicated for one operating system. I cannot run multiple operating systems on the same machine, right? Which means all the resources on the physical machine are wasted, right? So if I go for Windows, this is going to be completely dedicated for Windows. This is going to be Linux, completely dedicated for Linux. This is another drawback, right, with the physical machines. Now, when we talk about virtual machines, right, physical, let's understand what is a hypervisor now. When you talk about hypervisor, right, I think it will take some time. Let's do one thing because we started at 6 o'clock. There's almost more than an hour we have spent already. Let me give you a break. Okay. So, what's the time there? Just a second. Oh, what's the time there now? I just can't see it here. Okay, 9:40, right? Okay, we'll take a 20-minute break. We'll meet at 10 o'clock India time. Okay? Till then, just take a break. Don't talk during the break. Don't get involved into any other activity. Just relax for 20 minutes. Come back to the session, right? Don't get distracted with any other thing. Just take rest for 20 minutes. We'll be back sharp 10 o'clock, right? See you after the break. Hi guys, hope you're back from the break. Kindly raise your hands real quick before we start, or you can message me on the chat. Okay, where is that? Very good. That's nice to see. Hmm. Okay, nice to see you all. I hope you guys are enjoying this training. I'm pretty sure. All right, we are picking up now. Uh, we are setting up the foundation to this class, and I'm pretty sure that very soon we'll be able to get into those real-time topics. Okay, let's go back. Let's quickly have a look at our agenda. So today we started with data centers, right? We talked about what is the importance of centralized management system, right? We talked about what are data centers. Then we talked about why there was a need to get into virtualization, right? So far we discussed about the problems that we had with the physical machines. We'll discuss a little more about this, and then we'll move on to talk about VMware. Right. Okay, let's get to our favorite whiteboard. All right, now I was talking about um, that on a physical machine, you cannot run multiple operating systems at the same time. That's a major problem. But we need to know why is that? Why is it that you cannot run two operating systems at the same time, right? Because I have my RAM, I have the CPU, I have the hard disk, I have the NIC card, right? So I've got the hardware. I will deploy the operating system, which comes with the kernel, right? Now, can someone tell me why is that you cannot run two operating systems at the same time on a physical box? Okay, very good. RF has answered something. Very good. I think you are my previous old student. That's why. So I want someone to answer this. Kernel and OS are tied together. Very good. Shahid. Different UI and commands. Sayed. Very good, guys. Very nice. Ikram Ali has answered something. It will create confusion due to processor. All right. Very good. Brother Atik has answered we can have two OS, but on different partitions, right? Very good. Yeah. My question was why can I cannot run them simultaneously, right? So very good. Very nice, guys. Very good. I appreciate that. Yes. So most of you are right. The problem is with this kernel. It is like we're trying to say, I will have one foundation and build two different houses on this, which is not possible. You can have only one house, right? I cannot build another house on this same partition. It's not supported. So the limitation is from the kernel, right? So the kernel can actually talk to only um, hardware, only one hardware, that right? So I cannot have two kernels communicating with the same hardware. It doesn't allow. It's not possible because that's a limitation from the kernel. Now, when we talk about kernel, right? Every operating system has a kernel, right? So what is a kernel for Microsoft? Can someone tell me? What's the kernel for Windows? Windows operating system. What is the name of the kernel for Windows operating system? I got one answer. Someone says NT, someone says services, someone says BIOS. Okay. I've got right answer from few guys. Rian got from Ibrahim. Very good. Someone says CPU, someone says shell script, file system, x86. Interesting. You might have learned this in your school, right? Kernel for Windows is Microsoft DOS, right? That's the Windows kernel. See, many people are confused, right? So that's a very, very basic thing that most of us are still confused. Many have given wrong answers. Of course, few of you have given right answers. I appreciate that. So DOS is a Microsoft kernel. And this is not free because Microsoft has not they have not given the code of this, how they have written it. No one knows it, right? So they have got these APIs that they only know. So they have written the program on top of that. So they write Windows 2000, started with NT 2000, 2003, 2008, 2012, and 2019, and so on, right? Um, so Linux also has a kernel, right? So Linux itself is a kernel. On top of that, they write programs and they say REHL, CentOS, right? And TinyCore and so on and so forth. So that's a problem. This kernel has a problem. It cannot communicate with two CPUs at the same time. This is what gave birth to virtualization. They said that on the same piece of hardware, we want to run multiple operating systems because there are different requirements coming up from the customer. Customer says, I want to run few Linux-based applications. Within Linux itself, they have so many different versions, right? So they might say that few I want to run on REHL, few I want to run on CentOS, and some customers say that I've got to have Windows 2016, Windows 19 with some other applications running. So now you cannot afford to get a separate box for each type of operating system just to run that application. You will end up spending too much on that. We want to cut down that cost. So VMware came into existence. Can someone tell me in which year VMware was introduced? Does anyone know about it? Don't go to the internet and search and tell me. So people are giving answers like beyond 2000 and so on, right? The fact is they actually were already in 90s. What I know is they started in 1995, way before 2000. So it might be somewhere before 2000, right? But did you notice that in 1995, we didn't even have Microsoft Windows NT Server because no one really bothered to get into virtualization because they never felt that there was a need for virtualization. Just imagine a situation where in a village there are like 3 to 4 people living and you get a bus or you get a train, a huge train, right? You would be laughing at me and saying that why would I need a train when I've got like 4 to 5 people who would travel? All I need is I can go by car. Why do I need a train? Right? So that was like that. People felt that why do we need so many computers? Why do we need to save about hardware? Why are we even thinking about all that? Because the need itself is so less. That's why we never bothered to look into virtualization. But when the need increased, it's just like it's now getting overcrowded. They have realized, oh, we should launch train now. So there'll be more trains coming in. Instead of people going by car, going by bus, let's get a train, right? So there is where whenever there is a need, obviously you get into those enhancements. So virtualization came into picture. How does this hypervisor? So when virtualization was introduced, we keep talking about something called hypervisor. Now, not to be confused with the term because they have used different names for this, right? Hypervisor is nothing but it's just like an operating system. We don't, in virtualization, we call it as hypervisor. We don't call it as operating system. But honestly speaking, this is a virtualization operating system to be, I mean, to be more precise, I would say, right? So just like how an operating system manages the hardware, hypervisor also manages the hardware. But there is a difference, right? How this works, let's have a look at it, right? Now let me explain you this more of the architecture of this. Here is where people don't understand the concepts, right? So I'm teaching you something beyond basics, right? Let's understand that. Now, with the physical machine, we had this problem, right? Kernel can talk to only one hardware because it just can see that. Let's now understand this. Now, I will get a physical box, right? Then I will now install hypervisor on it. Just like operating system. There are many hypervisors available in the market, just like operating system variations you have. You have Windows, you have Linux, you have Unix, Macintosh. In that, like that, hypervisors also, there are competitors in the market. For example, you have from VMware, you have hypervisor called ESXi. From Microsoft, right, you have Hyper-V. You have KVM, right? And so on and so forth, right? And you have REHL also now in the market coming in. So there are different variations, but widely used ones are these two, ESXi and Hyper-V, right? VMware is a leader because, yeah, there is Citrix Zen app was also there. Yeah, I know that. Okay, so there are many in the market, Zen app. So let's say, but all I'm telling you, the foundation is same for all these, right? So I will install this hypervisor on the brand new hardware. So my hardware is here. I have got my CPU, got my RAM, my hard disk, my NIC card, right? I've installed it. The beauty of this hypervisor is this hypervisor is not like your kernel, right? It can basically uh, handle multiple requests. But still, this hypervisor is going to talk to the hardware only once anyway, but the way it works is different. Now, what we can do is on top of this hypervisor, I can create something called a virtual machine. Now, what is a VM and all that we'll look at later. Virtual machine. On each VM, now I can install, so let's say I have got, let's say some 100 GB of RAM. And I have got some, say, let's say some 30 cores of CPU, right? And some 1000 GB of hard disk, right? Now, because the physically I have got 100 GB, I can now assign, let's say 10 GB to this VM. To make it more simpler, let me just open a new page and we'll come back to this page. It is just like this. I build an apartment. Okay. In this, I have got flats. On top of this apartment, right? I've got this, I'm sorry. Water tank. This is a common water tank, but I can basically divide this and say I can give water connections to all these flats. And there is water here. And I can control how much water can go to each flat. Let's say I can say 10 liters will go here, 10 will go here, 10 go here, 10 go here, 10 go here. This is virtualization. In a physical machine, it's think like an independent house. You have one water tank here. You have another house, you have another water tank. The problem with physical independent houses, your water is assigned to this house. So if this house is going with 0% water, there is no water, and there is water here, you cannot share it here. That's a problem. Here, because it's common, we can start sharing it. Another good news is, let us say these people at this house are gone to some vacation. They are not available. So I can basically stop share giving to this guy that this 10 liters I can give it to this guy. Then maybe he can get 20 because he's not available, right? So we can basically share like this. And for independent house, you cannot do that. This is the major drawback between physical and virtual machines, right? Now let's come back to our previous one. This is what we were discussing. I'm doing the same thing here. I've got 100 GB of RAM. Think of it like your water tank on your apartment. I'm assigning 10 GB of RAM to this virtual machine. VM, think of it like your flat in the apartment, right? So I'm building these flats within this apartment in the form of virtual machines. And I keep assigning RAM to this. And the good news is, the question is, how are these operating system kernels now able to communicate with the same hardware simultaneously? Because in the physical machine, we have this problem, right? One kernel can talk to one hardware at one time, but they cannot talk simultaneously. But how are these able to talk now? Correct? So what this hypervisor basically does is, now let us say this VM has a kernel and then the operating system, right? Now, this kernel is actually going to talk to my hypervisor. Why? Why is it not talking to the CPU directly? The reason is, the beauty of this hypervisor is, this hypervisor is going to present itself to the kernel of this VM as the hardware. It is just going to imitate. It's just like it is pretending it to be the hardware. So it has got that ability. So it says that I am the CPU, and this virtual machine thinks that I am the only machine running on this entire hardware. Your VM will never get to know that there are also other VMs which are hosted on the same hardware, because my hypervisor is telling this kernel, I am the only one and you're the only one. There is no one else here. So kernel says, okay, as long as you're the only one talking to me, I don't mind. So kernel never gets to know that basically there is an upper layer added. This hypervisor is fooling the VM in other terms. It's telling that I am the hardware. It is not the hardware. So it says, I am the CPU. Tell me, what do you want me to do? So it tells, let's say I'm opening the notepad again. It double clicks, says, okay, open the notepad. Hypervisor says, okay, let me do it. Now hypervisor maintains a table. In the table, it keeps a record of all the requests which come in, right? So let's say VM number 4. It has to open a notepad, right? So all these requests go into a table. And then what happens is, and it just keeps looking at the table and says, okay, I have to just follow these instructions and keep working on them. So sometimes if all these VMs request at the same time, obviously it cannot just go and fulfill at the same time. So it's going to store that information in the table, and then one by one, sequentially, it will process. You might be thinking, will it slow down the virtual machines? The answer is no. Why? Because the hypervisor is so fast that it will not actually make you look like it is actually storing it in a table and then processing. It's just going to do it so fast that you don't get to know that. So now, if you see, all the credit goes to this hypervisor. That is why we call it as VMware, and that's why it is ruling the market now, because it has found a way in which we can now run multiple operating systems on the same hardware. Because now we are able to run it on the same hardware, now we can share the resources. Now I'll come to the point where we are going to see how we are able to save the hardware. Let's see that. Now let's work together and we'll do some calculations, right? I'm pretty sure you're going to enjoy this. Let us say we got an order from the customer and he tells us that we want you to set up a VMware ESXi server. We also want you to tell us how much hardware we have to purchase. Okay. I want you guys to, right. I want you guys to work with me to do the calculations. Now, there's a question in the chat. So is there a chance that hypervisor going bad? Yes, there are chances. The hypervisor might get corrupted. The hypervisor might get stopped, right? If this happens, what's going to happen is all these VMs which are running will stop functioning. But obviously, that's why we have VMware administrators, right? Who will troubleshoot and fix the problems. You will learn in the course, right? Obviously, tomorrow and day after tomorrow, you will see how we manage this, right? So there are problems that come up, but we know how to fix them also. We know how to tackle them, right? Yeah. So now let's see. I want you guys to help me in this, okay? Let's say we have got an order. We all are architects now, and there is a customer who says that I need like 5 Oracle servers. I need 5 domain controllers, right? So each machine, I'll keep a round figure because generally RAM doesn't come in round figure, but I will just keep it round figure. Each machine needs 10 GB RAM, right? So total will be 50 GB. Same thing for this. You need total 50 GB here. This is about RAM, right? 100 GB RAM is required to run these 10 machines. And they also say that I need, let's say, 40 cores of CPU. Right? Now we are going to set up a physical box. Creation of VMs is easier. I'm going to create 5 VMs, 10 VMs, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'm going to assign 10 GB RAM to each, right? That's what keep doing. So all this 10 GB each. You guys tell me, before even doing this, we need to buy the hardware, right? We need to go to the market, get a new box. The question is, How much RAM should I buy? You guys need to tell me on the chat. The requirement is to run 10 machines. Each machine needs 5 GB of RAM. Total requirement is 100 GB. Now, before we create the VMs, obviously we need a physical box and we need to install ESXi on that. How much RAM should I buy? I want you guys to guess and tell me. Some say 100, some say 50, some say 500. Okay. Some say repeat the question. The question is, my requirement is to run 10 virtual machines. Each VM would need 5 GB of RAM, 10 GB of RAM. Totally 100 GB RAM is required, right, to run these VMs. How much hardware do I have to buy? Some say 200 GB, some say 100 GB, some say 50, some say 128 GB RAM, some say 150, some 64, some 250. Oh my God. Some say depending on utilization. Very good. Okay, very nice. That's good to see. But I'll tell you the reality, okay, how it is in the real world. What do I do, right, if I get a requirement from a customer, correct? It basically depends on different organizations, right? Let me tell you. Now, if it is, let us say, I would say it is just uh, a shop, right? Maybe a retail shop or a wholesale shop. In that case, I would buy, instead of 100 GB, I will just buy 25 GB of RAM. Instead of 40 cores of CPU, I'm going to buy 10 CPU cores. You would be wondering why is that and how is it going to work? And I'm going to configure these 10 VMs, no doubt about that. I will still have those 10 VMs, right? I will still assign 10 GB RAM to each VM, no doubt about that. Question is, how is it going to work like this? Is it really going to work? I just got 25 GB, but I'm assigning overall 50 GB here, 50 here. Totally, it's 100 GB. But I only have 25 GB available physical level. This, if the request comes in, obviously it cannot cater these machines, right? How is it going to work? Right? I'll tell you. I'll tell you what happens. The reality is, as an architect, I know how these retail shops function, how wholesale shops function. Just think of it like a bank. Let's say there is a bank, HDFC, okay? It has got 10 customers. Each customer deposited 1,000 rupees, right? Into 10, 10,000 deposited in the bank. Now, the bank has to have an ATM machine and also put some cash in this so that people can withdraw. You guys tell me, is the bank going to put all the cash that they have got as deposits into the ATM machines? Will they do it or not? Does a bank put everything that they have in the ATM machines? No, right? So everyone says no. But you guys tell me why? Why not? Why they don't do it? Why they keep only certain amount in the ATMs? Why not everything? Any reason behind it? Not required. Very good. I think one answer is very good. Akram Ali has answered this question. He said, because not everyone goes to the ATM. Very good. I mean, most of you have given the right answer. So everyone doesn't need the money at the same time. Understand that, right? Most of us, we have all of our money in the bank. How much of us would require cash at the same time? We may not. Even if you're using GPay or PhonePe, whatever, you don't keep transferring at the same time, right? If I transfer now, you may not do it now, you might do it tomorrow, which means these banks are very smart. They know how much withdrawals would happen because they have that experience. They have that knowledge that how much withdrawals would happen on an average, right, on a particular day. Only that much they're going to put it. Similarly, as an architect, we also have an average. We know that if I'm running 10 VMs, so we don't do 10, obviously we run some 100 machines, right? If I'm running 100 machines on an average for a type of organization, which could be a financial company, or could be a retail company, or could be an airport, right? We know on an average how much they would be consuming. And all these 100 machines or 10 machines in our example do not ask for resources at the same time. If VM number one is asking for 8 GB RAM, the other four would not be asking that much. They might be just saying, staying at like 2 GB. So what we're going to do here is we know that this all will not come at the same time and ask for all the RAM which is allocated to them. We know that. That's why we are taking these chances. Yeah, if you might be thinking, what if all of these come and ask? In that case, obviously, it's just like all the customers go to the bank and say, we want to withdraw everything. The bank will say, no, it's not possible. We don't have that much. They will have to, they will make you wait. That happened, right? With many of the banks which get bankrupt, people stand in the queue. They don't get the money because bank doesn't have it, right? Same thing happens here. The chances are very, very rare that all machines come and ask for resources at the same time. We know that. If that happens, the blame goes to the architect who has incorrectly designed it. He has to know how things function. Only then he's going to propose this design. So what I do as an architect, we follow this ratio of 4:1, 2:1, 1:1. What this means, all the machines in the organizations um, which are unimportant, or maybe I would say testing machines, right? All such machines, we put it under 4:1 ratio, which means if the need is 100 GB, I will go with 25 GB only. 2:1, all the critical machines. So if the need is 100, I will go with 50 GB RAM. Business mission critical machines. Now, this 1:1 is very rare. We do it for mission critical, like if you're going for army, right? Indian Army, or in Saudi Arabia, we have a customer who actually makes the handles the U.S. Army, right? So they make this all the fighter planes and all that, right? That, or airports. I did a project for Oman airport, right? They were building a new airport in Oman. So we did the sizing for that airport. In that case, we did 1:1. Why? Because the government itself set these rules that we don't want to take chances here. You can't take a risk. Whether in this case, you will be unnecessarily wasting the resources, right? It's just going to be 1:1. So which means if this is 100 GB required, we bet buy all the 100 GB. But remember, this happens in most of very, very rare cases. Most of the times we go with 4:1 or 2:1. Now imagine if I'm going with 4:1 ratio for the organization, which means if I was spending 100 crores on physical machines, Now I'm going to just spend 25 crores. Imagine I have saved 75% of the cost to the company. Agreed? Understood, guys? Any doubts about it? Is this clear, guys? Please reply to me. Very good. Very good. Okay. Nice. 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 Okay. There's one question here from Suleiman, I think. What would be the ratio, Samiullah, I'm sorry, Samiullah. What is the ratio for online banking ATMs related servers? See, Sami, basically, for all the customers that we work with, we ask them which are mission critical machines for them. So they say that these are mission critical for us. So it's if it is ATM, it doesn't necessarily mean that it has to be always working 100%, right? It many times AC ATMs go down, right? The server is down, or kind of things happen. That could be one of the reasons where many customers go to all the ATMs, right? Maybe on the first of every month to withdraw their salaries. You might see that ATMs go down during that time. That's because we go with 2:1 ratio. 1:1. So we ask them which are your mission critical machines, which if that goes down, your entire business is kind of halted. In such case, we go with 1:1. But otherwise, even within the bank, right, we look for mission critical, non-mission critical, business critical, non-business critical testing machines. So there are different ranges. Depending on that range, we're going to decide what we're going to be doing. Is this clear, guys? Okay. All right. All right. Just give me a second, huh? All right. Very good. Very good. So now this all these hypervisors could be VMware ESXi or Hyper-V, or could be Citrix, or could be KVM. They work in the same fashion, right? Um, Now, yeah, there's another question, Abdul Moeed. No, this is not that I personally use it. This is all the architects in the market use it, right? This is a standard that how you size your hardware. Now, this is very important to save the cost of the organization, right? Because now, because this, just the reason is the hypervisor is able to help you communicate with the hardware simultaneously. Now we are able to do this. So resource sharing has now become easier for us. So now let's try and understand how this basically resource sharing happens, right? Let us say um, someone says, give me example of 1:1, 2:1, 4:1. Now 1:1 means if your requirement is 100 GB, you buy 100 GB of RAM. 2:1 means if my requirement is 100 GB, I'm going to buy 50% of it, 50 GB. 4:1 means if the requirement is 100 GB, but I'll still buy 25%, which is 25 GB of it. Okay. So again, this ratio we look at depending on the criticality of the machines and we assign it. Now let's try and understand a little more into this. Okay. Let's say I've got this machine and these VMs are in here, which are running now. Now, what happens is when you power on a machine, we know that it generally takes more resources. After that, it doesn't require that much. Now, let us say from the hardware, machine number one is asked for entire 10 GB of RAM. Maybe there was a backup running within the machine, the backup software consumed a lot of resources. Now the backup's completed. Now the utilization of this machine has come down. Now it is only using 2 GB of RAM. 8 GB is actually freely available. But the question is, will this machine say that I am done, I don't need resources anymore? And will this machine return it to the hypervisor? The answer is no. It will not. Once we assign the resources to a machine, it will continue to keep it. So the hypervisor is the one which is going to take it back. It is going to reclaim it, saying that if you don't need it, I'm going to take it back. So we call it as reclaim technique. So there are different techniques. We call it as transparent page sharing in VMware, TPS. We call it as memory ballooning. Memory balloon technique. These techniques are used to get the resource memory back to the hardware so that we can give it to some other machine, right? So how this works, this is going to be too much of discussion for you guys, right? But for understand that at least in the interview, if you tell them that there are techniques available using which the memory is reclaimed. The technique names are TSP, transparent space sharing. There's a memory ballooning technique. At least for a new guy, if you tell this is going to be too much for the interview. I'm pretty sure many interviewers, they themselves don't know how these techniques really function. So they may not dare to ask you how this really works. Even if you tell them, that's going to be really good for you guys, right? So reclaim happens like this. Okay, so now the entire machine is functioning in this fashion. I give resources, I take it back as soon as you're done, you don't need it, I take it back and I hand it over to someone else. So that resource sharing continues to happen. It's just like in the bank, someone withdraws the money, someone deposits. So one is withdrawing, another is depositing. So you just keep exchanging that same money with your customers. And VMware also does the same thing. So some machine needs the resources, the other one doesn't need it, takes it back and assigns it to the machine, right? So Fazil has a question. Now, Fazil, the memory reclaim technique is memory ballooning technique basically happens on the hypervisor. Transparent space sharing basically is done by the vCenter. So good question. But memory ballooning is specific to the hypervisor. It reclaims, but vCenter uses TPS. Okay, so far we are clear now about, let's go back, right? We are clear about the history of virtualization, right? How virtualization was introduced, right? Or the history of virtualization, why we came into virtualization, what were the problems with that, right? So architecture is clear now. We'll try to look at a little more into um, the the drawbacks of physical and the benefits of virtualization, and we'll move on to the other core concepts, right? Now, the other drawbacks that we had with physical machines was management was very, very complicated. For example, if I want 100 physical machines, right? Imagine the size of the building I need. So physical machine, right? Disadvantages is, I say, building footprint. Sorry, it's too quick to write it. Building footprint. This is a problem because if I need 100 machines, I would buy a huge building or take it for rent, right, and host it. That's the problem. Other problem is migration, which means if I want to move a physical machine from one location to another location, the problem is I would have to shut down the machine, so there is a downtime. Then you need a human, obviously, efforts. Someone has to carry that and then physically move it. So there is time consumption, there is resource consumption, in the sense physical resource consumption, and obviously there is downtime. So migration has been a problem. Um, Cost, obviously, hardware, cost of hardware, right? So you would have to use dedicated hardware for that. On top of that, um, networking being a very big problem, you would require physical switches, physical routers, for connectivity and all that. So that is another problem. So these are some of the issues that we really had. So maintenance was difficult with the physical machine. With the virtualization, now you don't need a huge building, right? Now with VMware, you can run over 2000 virtual machines on single hardware, which means if I want to host 2000 or 2000 machines, all I need one single box, create 2000 VMs on that. Just think of it that you wanted to write 2000 letters on a physical paper, or you have 2000 emails sitting on your inbox, right? It's 2000 papers, obviously letters that you've written, it would require space. You had to keep it somewhere. 2000 emails sitting in your inbox doesn't require any space whatsoever. They're just sitting in your laptop, right? So physical machines, too many machines if I buy, huge cost, right? And migration also for VMware virtualization, right? Easy migration. So you can migrate it live for there is one machine in Hyderabad, there is another data center in Bangalore. I can migrate it online. If I want to move these VMs, I can move it over the network. There is no downtime required either. Imagine if you're moving a physical machine from Hyderabad to Bangalore, you had to shut down the machine, or if you send it by the flight, you have to go to the airport, right? Put it into that cargo, send it. Someone has to pick up at the airport, go to the office, connect it, power it on. Imagine if you was doing for like 500 machines, what would happen? For virtual machine, it's just a matter of few clicks and you're there, right? So migration is a lot easier. Hardware cost, low cost. As I just gave you example, 4:1 ratio, right? So there is barely any hardware you're buying. Network connectivity, we have virtual networking. You don't need physical switches and routers anymore. Just one box is enough. So a huge amount of cost is saved with virtualization, right? So far clear? Okay. All right. Just 1 second. Okay. So let's quickly move on. Now we are going to talk a little more about the concepts in VMware, right? We will now try to understand, right, what is a virtual machine basically, and what does it really do? Just need to give me 2 seconds for that. I need to access my lab. All right. All right. Okay. My lab is coming up. I think it's just taking a while, guys. Just hold on. I'm launching the lab. So I just want to show you in the lab. So how does it really look like? Like I had sent an email to you guys. I'm not sure how many of you guys have checked it. I wanted you to create your accounts on the VMware hands-on lab. I don't know if you've done it or not. If you've done it, that's great. You have to log on to that. So let me just show that real quick, okay? How to do that. Okay, hands-on lab. Okay. Okay. So once you're logged into this hands-on lab, okay? People who have not done it, I'll put it on the chat. I want you to create your account, okay? And this is going to be helpful for you. You can always practice here, right? So which lab you need to enroll is, where is that? Cloud. We need a basic lab. Just 1 second. It should be part of Lightning Labs. Sex. SD-WAN. Just 1 second, guys. I'll tell you which one. Okay, VMware vSphere Overview Lightning Lab. Okay, this one. Yeah. You have to enroll for this one, okay? Put it on the chat. Okay. Oh, goodness. Just hold on. I think they have changed this. Just 1 second. Okay. So after you're logged in, right? All you have to do is just click on Start this lab. Just start the lab. And then just it just gives you guidance. Don't have to look at all that. I think you should start from page number. I'll tell you the page number. Not here. Yes. Yeah, you can start with page number 12, right? It tells you click on region, click on the book. Okay, so it starts from here. Click on region A. Hold on. I think it has to start with. I'm sorry, they have made some changes. I don't use it because I have, these are free labs available for public, and it's just need to have to get it. Introduction, and what? What's this? Okay, start with page number 11, okay? It tells you click on Firefox icon, right? So just click on it here. Then we go to page number 12. Then it tells you on the top you have region A. Then you need to log into this. Then it talks about logging in. You just need to put this, select the administrator account, right? And then click on this. So you just need to follow these on-screen instructions, do the lab. Okay, this was something that I wanted to show you. So what we'll do now is I'll just quickly show you. Uh, okay, someone is asking me to share the link again. 1 second. The link is here. Okay. Now what you're doing is the free labs available. I'll show you the real labs that we generally use. Okay. So this is the lab. Okay. I will launch so vSphere client is nothing but you have to use this tool to log into your ESXi hypervisor. So now I will log in and show you how it would look like. Okay. This is not required. Tomorrow I'll talk about the other concepts, but today we'll just see uh, how to log in. So I'm just logging in. Not this. Where is it? I think. Oh my goodness. I think I've launched the wrong lab. It's not the one. Okay. This is your ESXi server. When you log in, this is how it looks like. You have to log in from the browser. This is your physical machine that you logged in. Just like you log into your Windows machine, right? You get to see Windows. And when you log into your hypervisor, this is how it looks like for you. Okay. Then from here, we can start creating our virtual machines. These are already created, right? Tomorrow, I'll take you through how to create those VMs and all that. And more importantly, I'll teach about the deep dive settings inside it. So obviously, as I said, I'll take you more at the deep level from the basics. So I'll talk little basics, but I will also talk, which is something which most of the people don't talk, right? That I'll be doing tomorrow. So I will stop here today. I would want you guys to, yeah, I'll give you 30 minutes of time to explore the labs, the hands-on lab, so that tomorrow you should be at least able to do it yourself. Today, just want you to log in, try to do it. I know you may not understand much from it, but I just want to get hands-on to this. Um, Once you get the view of how to access and so on, then I think you'll pretty much be able to do it yourself. Um, so just go ahead and just log in and start doing it. And let me know if you guys have any issues. I think any other questions if you have. Some people have got some messages on the chat. Let's see. Do we need to register? Yes, you have to register. Okay, I've already sent you emails. I think some of you may not have got it or may not have read it. I don't know. You have to register with your email address. Okay. I want you to do it because this is lifetime free access that you get from VMware. So it's always good, right? If you want to practice, you can always do it. It is free of cost. There is no charge for these labs. Okay. Arif, not moving further. Are you logged in? I don't know. Yeah, each module will have some time limit. So, but you can extend that time. Don't worry about the time. Okay. Again, tomorrow you have to use the same session link, guys. There is no separate session link for each day. Okay. Use the same link to join tomorrow as well. Someone is appreciating. Very good. Someone is logged in. Someone is thanking you. Thanking. Okay. Some people are asking about the job market for VMware. I'll talk about it on the last day of the class about job salaries. Okay, don't worry about that. See, I'm telling you one thing. Um, at the initial stage, right? Don't worry about the salary. Okay. The reason is if you're new, you should focus on getting an expert into the technology. If you only look for salary in the initial stage, right, you will be picking up such jobs which will pay you more initially. But I'm telling you, that will not help you, right? Initially, you might earn better, but if you're not becoming an expert in an area, later on you will be in trouble, right? So at this stage, don't worry about the salary, right? Don't worry about um, uh, how much effort you're putting in. Just focus on learning the concepts while you're working. That's more important. If you get the concepts very clear, then the salary will obviously be increased, right? Companies will pay you at par. Another important thing is if you learn one technology at an expert level, then it becomes a lot easier for you to learn all the other technologies much faster. So because you will learn the art of learning, that's more important. So then you will say anything coming new in the market, you will not be afraid of it. It just looks like, okay, that's just a cakewalk for me. Anything that comes in, you will start, you know, learning yourself. So it's just going to be like that. For me, when I started my career, right, there was no virtualization, honestly speaking. We had Windows 2000, right? MCSC, Windows 2000, CCNA. That's something that I learned, right? I went to the institutions and learned. But when I got onto the job, all these things came in, right? VMware came in, Hyper-V came in, Veeam backup, right? All that, all these are new, right? I learned it myself. So because the foundation, when I learned Windows, right, 2000 or CCNA, CCNP, I learned it the way I should actually, because those concepts were clear, the rest all the things were clear for me, right? So think of learning, right? And you should have that desire to learn, right? And I'm telling you, the best way to learn is to teach. I teach your brothers at your home, right? Or teach your friends. Whatever you have learned, teach that. If you teach, right, that's the beauty of actually learning. When you teach, you get more doubts. And you go and start searching for doubts online, and you get more clarity. And then the more you teach, the more you start becoming an expert on the product, right? So make a habit of sharing your knowledge with others, and you will see that you one way you think that you're actually teaching, but it's actually learning for you, right? I myself am still learning, right? While I'm teaching, it's don't think that I'm just teaching. I'm also learning with you guys. Okay, carry on. I will just sit for some time. Then I think what's the time now? Okay, I think it's almost 8:40 now. So, okay, let's do one thing. We will close the session now. You can practice your labs whatever time you think like, right? Spend some time. Um, I hope you guys have enjoyed the session today. And I'm pretty sure tomorrow you will join on time. And whatever was learned, right? I will obviously share the recording. I've got your email addresses. You can download the recording, listen to it one more time. You might get more doubts, just listen to it. And make notes about whatever has been learned. And tomorrow I will see you at the same time. I really thank you so much from the bottom of my heart. I appreciate your participation in the discussions. You've been really kind, always asking questions, replying to my answer questions, and giving the feedback. I really enjoyed teaching you. I wish you best of luck, and I will see you tomorrow again. Thank you so much again, and have a very good night. Bye bye.